Okay, so experimental probability. Okay. Well, really, we're going to compare two types of probability. Okay, everything we've done up to this point has been what we call theoretical probability. And if it's theoretical, what does that mean? What is the base word of theoretical?
Theory.
Yeah, it's based on a theory, okay? And if you think about a theory, it's basically what is supposed to happen, okay? So theoretical probability is what is supposed to happen.
I feel like theory is more of an idea. Not really supposed to happen.
Kind of. It's kind of like a rule that, but here's the thing. If I flip this coin based on theoretical probability, what is the, why aren't you taking notes? Write this stuff down. Okay. This should be, I should get, how many, if I flip this 10 times, how many should be heads?
5.
5, and how many should be tails?
5.
5. Because based on theoretical probability, every time it's a 50% chance of getting a heads or tails, right?
So then,
Okay.
certain games like Halo, Halo's a theory,
Oh my goodness.
but it's not predicted to happen. I'm using
Why
Halo.
Okay, experimental, okay, is based on results of a trial. When we're talking about trial, we talk about actually doing an experiment, okay? So if I have this coin, okay, theoretical probability tells me if I flip it 10 times, I should have 5 tails, 5 heads, right? Could that happen? Good, right? Okay, Jimmy, you keep track of these. I'm going to flip it 10 times, all right? Then we'll write it up here. Okay. Heads. One. Tails. So far we're good, right? Heads. Tails. 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 Heads. Heads. So what are we so far? 4 and 4. Tails. So if this one's heads.
There's no way.
Okay.
No.
All right. So when we did the first trial, tails was 6, heads was 4. Okay. So if we base this on theoretical probability, it should be what? Tails 5, heads 5. So are they different? Yeah. Now if I do this again, is it going to match this or is it going to match this?
We don't
I
know.
know, right? Do it again. James, keep track. Heads. 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 Heads.
I'm guessing this one's tails.
Tails.
I knew it.
Heads. Heads.
Oh, okay, I don't have any more fingers.
Heads.
Seven.
Tails. Tails.
7-3 then.
That one was 7-3. Okay.
That's crazy.
And it was right. Okay, so
No, it's not right. Yeah, no,
it was right. Okay, let's do it one more time. These are close, right? If I add these together, this is 9 and this is 11, right?
Yeah.
11 out of 20. Let's try it again. Tails. Tails. Heads. Tails. 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 Heads. 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 Tails.
Oh,
6 and 4.
6 and 4. Okay. So if I add these together, okay, how many times did I flip it? I did it 30 times. Now, please don't talk on copy. I did it 30 times. How many of them were tails? 12 plus 3? How many of them were heads? 15. So after 30 tries, did I match the theoretical probability?
Yeah.
I did, right? Now, Zach, Is that random? I mean, could I have controlled that?
No.
Is that always gonna happen or
No.
no way?
No.
Exactly.
That was totally random. Just check it out. If I do it again,
Let's do it again. Let's prove it again.
hey, it's your time. Let's try it again.
No, let's not do it again.
Let's try it. Dylan, you keep track.
Oh,
It's probably blocked.
Dude, it's an H or a T. Come on. All right, forget it. James. Heads. 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 Tails. 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 Tails.
Tails?
Tails.
Add 6 and 4.
So what was it?
6 and
Oh,
4.
4 and 6.
6 and 4. Okay.
What a comeback though. Look at the headlight.
Okay, 10 more. Here we go. Ready? James, move fast.
Got it.
Tail, heads. Heads. Tails. Tails. Heads. Heads. Tails. Heads. Heads. Heads.
73.
The 3 heads?
Yeah.
Okay.
Wait. Wait.
Hold. What's that? One more time. Tails.
Tails.
Heads.
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 Tails. Heads.
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 Heads. You've already broken it.
Heads.
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 Tails.
73.
7 and 3 heads, right?
Yeah.
All right.
That's what you did before.
Nah, there's.
This was different, right?
Yeah.
What is this?
It's 12. And
12 out of 30. What is this one going to be?
18.
18 out of 30. Okay. So
That was close.
if I was to take any one of these, okay, is this different than this? If I took this right here, this result, and I said I have a 70% chance of flipping heads, is that true?
Yeah.
It's true. Why? Because it's based on what? Based on this, right? On the experiment. Okay? If I took this one and I said I have a 60% chance of getting tails, is that true?
Yeah.
Okay. If I said, if I had a commercial, I opened my own casino. I said, every time you flip a coin, if you get heads, you win $1. If you get tails, you pay me 50 cents. Okay? And I said, but you have a 70% chance of winning. Am I telling the truth?
No.
Based on one.
Based on this, I'm telling the truth, right? In theory, though, if I did this 100 times, here's the thing. The more trials you have, the closer it's going to get to this. If I did this 100 times, it might be 75-25, but it also might be like 52-48. Okay? Did you see how they got closer the more I did? After this first one, they were only 2 apart. If I had started with this one, they would be 4 apart. But the more I did, the closer they got. Does that make sense? Okay? So in order to get something closer to the theoretical, you have to do more trials. So let's say, based on this one right here, okay, that's 70% heads, right? 30% tails. If I did, this was 7 out of 10, okay, this is heads. If I did this, if I flipped a coin, based on the result, if I flipped a coin 500 times, how many would I expect to be heads? What is this? You guys remember doing this? What is this thing called? Close. The proportion, okay? And if you think of a proportion, we have a missing value right here, right? I should be doing this on here so people can see this. Okay, look. Hang on a second, James. So if I flip a coin, does everybody have this written down? If I flip a coin, 7 out of 10 were heads. Don't talk, please. So how many out of 500? This is going to be X. Now, there's two ways I can do this, okay? If you remember, if this number right here happens to be a factor of this, it's pretty easy, right? Because 10 times what gives me 500? 10 times 50. And I do the same thing up here. What's 7 times 50? So X would equal 350, okay? But if that number up there is not a factor, okay, then how do I solve a proportion? Does anybody remember? You get cross products, okay? So let's say I do another experiment. I tell you what, draw a circle in your notes. Okay, draw a circle. And let's say that, let's say I have a spinner. Okay, and let's say that on that spinner,
You make it circle away.
all right, so half of this we'll say is red, okay? And then we'll say over here, ooh, sorry, we'll say from here to here, let's say this is blue, let's say this is green, and this is also blue. All right, so if I have a spinner here, okay, let's say that I spin this, well, anytime I spin it, can you tell me the probability of getting any one of these colors? What's the probability of getting a red? Look at it. 50%. Why? Because half of that thing is made up of red, right? So let's list our theoretical probabilities. Okay, red would be 1 out of 2 or 50%. Okay, what about blue?
75.
Not 75.
It's like
45.
30. Okay, look, Jace is right. This is 25%, right? And then we have half of another 25%. What's that going to be? Okay, so this is about 37.5%. And let's say the green is going to be 12.5%. That's based on theory, right? So if I spin this thing 100 times, how many times in theory should I land on red? 50. How many times should I land on blue? 37.5. How many times should I land on green? 1.5. Okay, does that make sense? Now, once I do this, let's say that I have a table here with my results, okay? Let's say that I actually spin it 50 times. Okay, and let's say that I got green 18 times. Let's say I got blue 8 times, and I got red 24 times. Okay? So if this is, first of all, this is theoretical probability. What are these results going to be? These are based on experimental probability, because this is experimental probability. Okay? So if I ask some questions on this, based on the results, what is the probability of spinning green? What was key about what I just said? Based on the results. Okay? If I said based on the spinner, what am I going to be referring to? Theory, right? Theoretical. But if I say based on the results, what is the probability of rolling a green? Well, 18 out of what? 50. Which would equal what percent? If you divide 18 by 50, you get 0.36, so 36%. Okay, now is that even close to this green?
No.
No. Could this happen?
Yes.
Could,
Oh.
right? What about the blue? What percent do I have of rolling a blue? Okay, blue would be 8 out of 50. So 16%. Is that close to this? Not really. What about red? What percent is red? 24 out of... That's pretty close, isn't it? What percent would this be? 48%. So which of the three were close? Just the red, okay? Does that make sense how we found that? And we're basing that off of theory. So if I asked you, let's say we spin this, say I spin this thing 125 times. Based on theory, how many would be blue? Based on theoretical, how many blue? How can I figure that out? Come on, think. Based on theory, how many can I expect to be blue? What am I going to use? Am I going to use my theoretical or am I going to use this?
Theoretical.
Theoretical. So this is 37.5 out of how many? 100. That's based on 100, right? Okay. So if I have 125, how am I going to find this? Cross. This is where you use your calculators. Cross. Come on. Cross products. Okay. So multiply 37.5 times 125. Do that. 37.5 times 125, and I get 4687. I'm gonna erase some of this stuff. You guys got to follow me. Okay, 4687.5, right? Okay, and what's x times 100? 100x. Okay, divide each side. Divide that by 100. What do you get?
46.
So 46.8. Well, you can't get blue 46.8 times. So what would I say? About what?
47.
Round this to the nearest whole number. So this would be x equals. So if I spin this thing 125 times based on theory, I would get about 47 blues. Okay? What if I said based on experimental? Figure it out. Go ahead. Figure it out. Based on experimental, how many would I expect to have as blue? How many are blue? 8 out of what? 8 out of what? 50. Trying to find x over 125, right? So can I show you two ways to do this one? Because you're going to have one very similar to this on your worksheet. Okay, I can either find my cross products. Okay, what is something that is the same value as 8 over 50? Could I do 4 over 25? Is that the same value? Yeah, and 25 times what gives me 125? 5. What's 4 times 5? So I would expect to get 20 blue if I rolled this 125 based on the experimental probability. Okay? Does that make sense how I found that? Yep. All right. You want me to do another example or are you good? I'm happy to do another example.
I want to flunk this on the test.
Okay. I'm going to use one from your worksheet. Tell you what, I'll pass this out and I will go over, a couple weeks. Okay. Yep.
So back to your casino, you say you get eggs, you get $1, you get toast, you get 50 cents.
Oh,
I know, but don't you have a higher percentage chance to win money in that situation? Yeah, because it's just.
I just want to either way.
Mr. Percy, you get both sides.
Huh?
You get both sides.
Oh, it's easy. The tournament.
Easy?
Oh, you're funny.
Okay, let's look at the front side. Okay. Pass those back so that we can look at them. If you would look at the directions on the front side, it says use the table that shows the results of rolling a number cube, which is a die, just like this. Okay? I don't want you to get confused between theoretical and experimental. Okay? If I use the table that shows the results of rolling a number cube 50 times, based on the results, what is the probability of getting a 5? What does that say on number 1? Put your head up, please. What does number 1 say? Based on the what? Results. Okay, well, how many 5s did we get if we rolled it 50 times? 10. So we got 10 out of 50. Can I reduce that to what? 1 over 5, which would be what as a percent? 20%. I would have a 20% chance based on the results of getting a 5. Now, do you know on a number cube how many sides are there? 6. Do I, based on theory, have a 20% chance of getting a 5?
On a number cube?
Based on theory. Based on theory, no. Okay, so look at number 2. Based on the results, how many would you expect to occur in 300 rolls? Well, what do you already know? 10 out of what? 50. So how many would this be? 50 times what?
300?
6?
Oh, my.
10 times 6? So I would expect 60 of them to be 5s. I'm giving you answers here in case you're not writing this down. Okay, number 3. What is the theoretical probability of getting a 5? Does that have anything to do with that table right there? No. How many numbers are in a number cube? 6. How many of them are 5s? 1. So what's that going to be? 1 over 6, which when you do that on a calculator is about 16.6, right? Which would be about what? About 17% chance. Okay? Based on theoretical probability, how many 5s would you expect to occur in 300 rolls? How many out of every 6? 1 out of every 6, right? So how do I get from 6 to 300? 6 times what? 50. And 1 times 50 would be 50. Okay? This is not that difficult.
Is that easy or not?
No, it's not. Okay, so when it says compare the theoretical probability to the experimental probability, and it's just talking about rolling a 5. Okay? Based on the results, I have a better chance of rolling a 5 than I do in the theoretical probability. Make sense? Okay. Keep going then. I've done the first 5 for you. Keep going.